start when we deal with the data. So first of all, what we do is we start the process, as we explained before, guys, if you remember, we start the process by just having an observation. So if you had seen something that is strange, you can, we call that by the observation. And usually you come up with this observation and we write this observation as a research question. So the first step is to represent this observation as a research question. And when you write this as a research question, this question, it should be clear, it should be measurable, it should be something we can evaluate actually. After we write our research question, we move on to the next step, and at which we try to generate some theories, as we said before. So we generate some theory, okay? And this theory can be can consist of a number of hypotheses. So we generate a number of hypotheses, and our task would be to test those hypotheses usually. Now, for those hypotheses which we test, they can be actually, they can be like, or we will see like we have to define the null hypothesis as we explained before, and we have to define also the alternative hypothesis. We have also, when we generate the hypothesis, we have to identify the variables. So we have to identify the variables, and when we identify the variables, we have to specify which one of those variables is independent variable and which one of those variables is dependent variable. So this is what we do when we generate the hypothesis. After that, we start collecting the data in the first step. So if we saw something, we write that as a research question. We assume something like a theory, and we write like different hypotheses out of this theory. For each one of those hypotheses, we try to write the null hypothesis and the alternative hypothesis as we explained together. And then we try to define what independent variables we will need to prove or to disprove this hypothesis, and what dependent variables we have as well. After we do all of that, we start to collect the data. So we collect the data, and sometimes, just for your information, instead of collecting the data, we might generate the data. So collect or generate the data. Now, when we collect the data, we have to, or when we specify, when we generate the data, whatever we choose, you know, any one of these two options, we have to determine actually what data we have to collect and how shall we collect the data, or what data should we generate and how to generate these data. And we have to specify also some other metrics or some other things, something like, you know, the type of these data. As we explained before, guys, data can be classified into two main categories. So any data, whether it was collected or generated, or any type of data, it can be classified as quantitative data, or qualitative data. And quantitative data, it could be like nominal, as we said before, and it could be ordinal. When we say nominal, we're talking about categorical data that contains something like just names of things actually. So we have, let's say, different colors, and there is no preferences between these colors. None of them is better than the other one, and that's what we describe as ordinal in this case. If any one of these values has like priority, or those values can be compared, in this case we would describe them like as an ordinal. And we have qualitative data as well, or we mean by that like not categorical data, and these can be classified also into two different categories usually. So this could be like continuous data, or it could be discrete data. So we have continuous data such as like any number that is continuous number, something like length, like weight, you know. So with those numbers, we can have decimals. Actually, discrete data, it's just some accurate numbers. Something like, let's say, age, let's say. Usually we describe age as discrete, or something like, let's say, quantities. So we can talk about, let's say, 4 apples, 5 apples. So we don't have, let's say, decimals, you know, pieces, usually. And we have to specify also, when we collect the data, we have to specify if these data which we collect, it's a sample of the population, or it does represent the entire population. So we have to specify, is it data from sample which is taken from the population, or does it represent it, or that's the entire population, and we have the data about the entire population. Usually, with sample from population, we can do our study on the sample, and then we can just derive from that some information about the entire population. In some rare situations, we can just, if we have just data about samples from the population, we can as well, we can just use a technique which we explained about before, which was called bootstrapping, just to generate something that represents the population. We have also to determine if these data, you know, sometimes these data, it could be like, which we have or which we generate, it could be like structured data. It could be sometimes semi-structured. So if it was, let's say, data in tables from database management system, we collect these data, then that will be described as structured data. It is already organized in tables. If it was like not fully structured, but it was, let's say, comma separated, let's say, or it was, it contains sort of structure like XML data, then we describe these data as semi-structured data. If it was not structured at all, just some text, then that will be unstructured data actually. Sometimes we might have special type of data which we describe as metadata. Now, metadata, it's a data that describes other data actually. Let's say if we have data that describes our website, data that describes the tables which we have in a database, then we describe these data, or we call these data as a metadata. So whatever the type of the data, whatever, if these data represent like sample from the population, or represents the entire population, or it's a data which we got, you know, as a result of generating a bootstrap, or it's a data which we got as quantitative data or qualitative data. We use these data in general to do the analysis, and that's the fifth step, which we would like to talk about in details. So we collect these data and we start the data analysis step. So we have step number 1, step number 2, step number 3, step number 4, and step number 5. Now, it's important, guys, that sometimes we might start from step number 4. So sometimes we follow this sequence from 1, 2, 3, 4, and we do the data analysis. So we come up with observation. We make it as research question. So we make a research question from observation. And then we generate the theories, we generate the hypothesis, we collect the data, we generate the data, and then we move and we do the data analysis. Or sometimes we might have the data and we try to figure out what to do with these data. So sometimes we can start just from step number 4. We don't have any observation in mind, we don't have any theory in mind, we don't have any hypothesis in mind. We have the data and want to see what we can do with the data. So this could be like another route which we can follow. Now, talking about data analysis, let's see what we can do with these steps. So I will just remove everything I wrote here, and I will talk in specific about step number 5, which is called data analysis. Now, to be honest with you guys, when we talk about data analysis, we don't talk about analyzing the data straight away. Usually, we have to prepare these data for analysis. So before we do the analysis itself, usually we try just to discover the data which we have, we might need to do sort of pre-processing. We might need to describe the data, apply some queries, and then we do the analysis really. So sometimes when we say data analysis, we talk about all of those steps together. But for me personally, I do prefer to make them like as different steps, as 1, 2, 3, 4 steps. So I do prefer to talk first of all about data discovering. When we talk about data discovering, what we do actually, we have the data. So let's assume that we have the data as a table or as a data frame, and we try just to discover these data. When we discover these data, guys, keep in mind, we try just to, we have different techniques to discover the data. So we can just have like visual inspection of the data, and then we can just let's say we can plot the histogram. We can plot, like we can use pie plot. We can use like scatter plot or just a line plot, and we can just use like box plot. So for each one of those, we can just see the data from different perspectives actually. So for example, when we plot the histogram, we can figure out, is the data normally distributed? We can see, do we have any skewness, let's say, in the data? We can figure out, do we have any kurtosis, let's say, in the data? So we see the data from different perspectives, and we try to discover what is the distribution of these data. We can also discover the data. So we talk about data discovery, guys. We can discover these data using some non-visual technique, you know. So we can just use, let's say, central tendency metrics just to see the data. So we can calculate, let's say, we can find the mode, we can find the mean, we can find, let's say, the median. We can just see also the dispersion of the data. So we can see the range. We can figure out the quantiles. We can see the variance. We can see the standard deviation as well. So all of that, all of these steps which we do here are related to data discovering. We just try to discover the data, to see what is this data. Now, after we discover the data, if these data which we deal with, was data about sample, not about the population. So what we try to do, we try to elaborate on these metrics which we had, and we try to drive. We try to just to infer or to get some indication about the population. So we try to see what is the population. Does this mean which we calculated represent the population? So this mean which we calculated here, it is for the sample. So we have the sample here. So this is just sample. If the data represents just sample, we try to see, does this mean which we calculated, you know, using some methods, you know, just does it represent the population? In order to see if it does represent the population, we have to figure out how much does the sample reflect the population. How confident are we? And here we have the terms which we explained before. So we have the term like the level of confidence, if you remember. We mentioned about another term, which was the confidence interval. So we use these terms actually to figure out if these mean which we calculated here, does it represent the population? So how confident are we? And we try to figure out if there is like an error. We try to measure the error. How confident are we? about this mean, and we try just to calculate the error. So we try to generate instead when we describe the sample, we get the accurate measurement which we got. So this is the mean. But when we try to generate that, or to get some indication about the population, which we don't know exactly, we only have metrics, we only have the sample. So we try just to generate like range or a range of like a confidence interval, sorry. So we try just to generate confidence interval and by adding like small error actually, which we can calculate if you remember. So this error, it can be calculated using, if we want to just talk about the mean, we can just calculate the error using like z multiplied by s over square root of n, where z, it's the value which we can get from t distribution or from normal distribution. So we can assume that this sample which we had, it was taken from a population that is normally distributed, or that is similar to normal distribution but has small number of instances, that follows like t distribution. So according to the type of distribution which we according to the size of the sample which we have, if the size was less than 30, as we explained before, we assume that the population follows t distribution. If the sample size was larger than 30, we assume that the population follows normal distribution, and we can calculate z according to this assumption. So we can just calculate the degree of freedom and the size of the sample, and we can calculate z from the tables, as we said, using the given level of confidence. So you can just determine, okay, I want to just see with this level of confidence, what will be the confidence interval for the mean, or what will be the confidence interval for the population. So you can just find out the population, find out the proportion of the population, as we explained before. You can just calculate the error if we're talking about the mean using this equation. If we're talking about proportion, we can calculate the error, as we said before, using z multiplied by the square root of p hat 1 minus p hat over n, where z, it's the value under the curve for normal distribution, or the area under the curve for t distribution. We can get z from the tables or from using R, as we will see later on. So that's what we do with data discovery. We try to discover the sample, and we try from this sample, we try just to see if we can predict something about the population, if that's possible. Now, sometimes, or in most situations, this description or this discovery of the data might tell us, even before we move on and we try to predict something about the population, we might notice something that has to be modified, in the data which we have already. So sometimes we might need just to add some columns, to remove some columns, to add some rows, remove some rows. Maybe we need to standardize the data. We need to delete the outliers. We need to remove the missing values. We need to add or remove some columns, as I said. So after data discovery, or sometimes before, and these two steps, actually, they work like in parallel usually. So we do sort of pre-processing, in which we try to standardize the data, try to detect and remove outliers. We try to add or remove, let's say, some columns, maybe, or rows. We can just deal or handle missing values. So that's what we do in this step in specific. After that, we might want or we might do sort of, so these data processing, pre-processing, keep that in mind, guys. So sometimes we do it before the data discovery, sometimes do it after. So sometimes we discover data, we get back to pre-processing, we get back to discover, we get back again to do pre-processing. So we just do it like forward and backward, and just to be sure that our data satisfies our needs actually. After we do data pre-processing, we might need just to do sort of queries on the data sometimes. So we can just apply different types of queries. So maybe you can just, so you can just get something like, sort of, you can just get some request, let's say. You can select, let's say, all rows, satisfies, let's say, certain condition, whatever condition number 1. You can, let's say, select all columns, they satisfy condition number 2. You can, let's say, select all employees who work, let's say, in certain department. You can figure out all, let's say, students with grade greater than, let's say, or less than, let's say, the mean. So you can just apply some queries, and that will be part of the analysis as well. What we explained about is the next step actually in this course. As part of the analysis, what we can do also, we can do something which we explained as hypothesis test. So in hypothesis test, actually, we have different types of tests which we can apply, as we explained before. So if I had my data, when I look at my data, which I have right now, if this was, let's say, the data, whether the data which I have represents the entire population, or it does represent, as we said before, just a sample from the population, we can just usually apply different types of tests. If the data represents the entire population, so there is no need actually to apply these hypothesis tests, because I have the population. I can figure out whatever I want. I can see if the mean in this column, let's say, equals certain value, if the mean in these two columns equal to each other, because I have the actual data. I have the data for the entire population. But in most situations, as we said, we don't have these data. We have data about sample from the data. And that's why we need to use hypothesis test. So we use this sample which we have to predict something about the entire population, to see what is the entire population, to see if this variable in the entire population has certain mean, or if these two variables, let's say this column and this column, in the main population, in the whole population, they have similar mean, let's say, or one of them has mean which is greater than the other one, or mean that is less than the other one. So that's what we try to do actually in the hypothesis test. We have some hypotheses, as we said before, and we try just to test each one of them, because we don't have the entire population. We have the sample, and we try just to think about the population. So all of that will be done usually with certain level of confidence. So we determine level of confidence, certain level of confidence, and we can apply different types of tests actually. If the variables which we deal with are continuous variables, okay, when we have continuous variables, then we have 3 different types of tests, or 4 different types of tests which we can do actually. Those are the ones which we explained about. So you can do 1 sample t-test. You can do also 2 samples t-test. You can do also, you can do paired 2 samples paired test actually, paired t-test. You can do also ANOVA test. So if you had just one unique variable, then you do 1 sample t-test. If you had 2 continuous variables, you can do the first one, the second one. If you had more than 2, you can use the third one actually. So this one is with 1 variables. This one is with 2 variables. This one is with 3 and more. Now, for each one of them, we have null hypothesis and we have alternative hypothesis. So for this one, we have null hypothesis and we have alternative hypothesis. The null hypothesis, which we have usually with one sample test, is the mean of the variable which we test equals to certain value. So the alternative hypothesis will be the mean of that variable is not equal to that value. So that's what we see. So we want to see, is the mean of age equal to, let's say, 50, according to the sample which we have? Is the mean which we have not equal to 50? So that's what we test. We have the alternative and we test, we have the null hypothesis, and which is the situation which we have right now, which we assume we have, and we have the alternative hypothesis, which is something we want to test actually. This could be greater than, less than as well. And we explained, if you remember guys, when we talked about hypothesis test, that we have that these tests can be classified into 3 different types actually. It could be left tail, sorry, it could be left tail test, or it could be 2 tails, or it could be right tail. So any one of those hypothesis tests could be one of these 3. According to the sign of the alternative hypothesis, we can determine if it was left, 2 tails, or right tail actually. So usually with one sample test, that's what we do. With 2 sample tests, we have the null hypothesis is the mean of the first variable equal to the mean of the second variable? And the alternative hypothesis will be, in this case, the mean of the first variable is not equal to the mean of the second variable. It could be the mean of the first variable is greater than the mean of the second variable, or the mean of the first variable is less than the mean of the second variable. When we do paired test, actually, we have the same assumption, but the only difference between the 2 sample test and the paired test, actually, that paired test, we have the groups actually, both of them for this type of test actually. These 2 groups, the test was applied on 2 groups, same test was applied. So let's say sometimes it could be like certain medication applied on that group, and then it was different medication was applied on the same group. So we have like same group, similar thing applied on that, or test was applied on this group 2 times, and want to just, so these groups are related to each other. So these variables are related to each other. Same entities. I applied 2 tests on the same entities. That's why we describe that as paired group. So with paired group, we have the same. We have similar actually null hypothesis. So we can just say these 2 groups or 2 variables are equal, which means the mean of the first one equals to the mean of the second one. Or the alternative hypothesis will be these 2 groups are not equal, which means the mean of the first one is not equal to the mean of the second one. With ANOVA test, we have, as we said, we have 3 or more, we have number of variables actually. So what we do actually, the null hypothesis in this case would be mu1 equals to mu2 equals to mu3, and the null hypothesis is one of them is not equal to, so they are not equal to each other, so which means one of them is not equal to, so one of them is not equal to the other one. So that's what we test. So that's what we do when we have continuous variables. In some other situations, we can have actually, categorical variables. So we can just have categorical variables. Now, if we have categorical variables, we apply different type of tests. Keep in mind, when you run any one of those tests, which like the continuous ones, you will need actually to do or to calculate something which we explained before, which was degree of freedom, which is equal to the number of samples minus 1. With categorical variables, we will need to use degree of freedom as well, and that will be the number of columns minus 1 multiplied by number of rows minus 1. So the way we calculate the degree of freedom for continuous variables is different from the way we calculate the degree of freedom for categorical variables. When we talk about categorical variables, we have usually we don't use a t-test or a normal distribution, but we deal with chi-square actually distribution, and that's why we describe tests which we applied on these type of variables by chi-square test actually. And these could be like one of three tests mainly, which are according to what we explained actually. So it could be like good of fitness, you know, sorry, goodness of fit test. So this one test, you just make them like this. Okay. So goodness of fit test. So in these tests, we have also a null hypothesis and alternative hypothesis. And the second type of test which we can run is test of independence. And finally, we have the test of homogeneity. So for each one of those, let me just remove what I wrote here so that I have some space. Just do it here. So in goodness of fit test, we test actually the null hypothesis will be that the stated distribution fits what is expected. So we have something right now. We have some selections made by people, you know, let's say the color they prefer, and we want to see, does this selection fit with what we expect? So does the number of red, you know, selected by these people, and the number of blue colors selected by these people, and the number of green colors selected by these people, you know, let's say we run an experiment on 100 people, and some of them selected red, some of them selected green, some of them selected blue. We want to see, does these numbers fit with what we expect? That's what we want to, that's the null hypothesis, it fits. And we want to see the alternative hypothesis, the stated distribution does not fit with what is expected actually. For test of independence, what we try to do actually, we try to, the alternative, the null hypothesis, let me just have some space. Okay. So in these test of independence, we have the null hypothesis. We have two categorical variables in this case. So we try, so keep that in mind, guys. We have test of independence, and we have the last one, which we explained about, that is test of homogeneity. So in the first test, guys, usually we have one variable. We have something and we have something expected. This expected thing, if we have the expected values, then we compare between these two. But usually we have something, it could be like the expected to be equal. So this could be run on one or two variables. If you have the expected value, then you have two variables. If you don't have the expected value, but you expect them to be equal, then you can just calculate this expected value actually. For test of independence, we have two variables, and we want to see that these two factors are independent. So the null hypothesis, the variable x and the variable y are independent. They are not related to each other. And the alternative hypothesis will be X and Y are not independent. They are related to each other. So that's what we try to test actually. With test of homogeneity, we have two groups and we want to see are they equally distributed. So the null hypothesis will be group X and group Y are equally distributed. Okay, and the alternative hypothesis, X and Y are not equally distributed. So we have two variables actually want to test. I hope it's clear, guys. Now, we explained about continuous variables, we explained about t-test, and we explained about chi-square test, and we have other groups of tests actually which we can run. So we can just expand that, but I need just to remove everything I have here in order just to continue my explanation. So talking about hypothesis test as well. We can also we can run a group of tests where we don't know what type of distribution. We don't have any assumption about the distribution. So we call them, let's say, we call them in this case a distribution-free test, and we describe them as non-parametric test. So with this type of test, this could be like one sample, let's say, Wilcoxon test. It could be also Mann-Whitney test. It could be Kruskal-Wallis test. It could be like Friedman test and some other types of test as well. We have some, we can just also run like correlation test. We can run also like Fisher exact test. So we have all of those hypothesis tests, and you select the test according to your requirements, as we said before. If you come up with a hypothesis, then you run the appropriate test. If you don't have like certain hypothesis, you have the data, you should create the hypothesis by yourself and you should figure out the appropriate test. So you try to discover, you try just to see, does the first variable has equal mean with the second variable, let's say. If they are categorical, then you can use chi-square. If they are not, you use, let's say, t-test and so on. What we explained also, we said in data analysis, so we said data analysis step, we explained about data discovering the data. We said in data analysis, usually you can do pre-processing. Usually we don't classify that as part of this, by the way, as I said, guys, keep that in mind. Data pre-processing is a step that comes before data analysis, but in some references, you might see it as part of it. We can just do also like different types of queries. We can do hypothesis test. And we can just use these data just to create sort of sort of prediction as well. So sometimes they classify regression as part of this process, which is something I don't prefer to classify it as part of this. But let's just assume that it is part of this. So we can have the regression and pre-processing. Usually we don't consider them as part of data analysis. Pre-processing is a step before data analysis. Regression is another step, that in which we can just get models, from the data which we can use for prediction. But anyway, for regression, guys, talking about regression, as we said before, what we try to do, we have two types of regressions, as we said. We have single regression and we have multiple regression. with single regression, we try just to find the line that fits the data so that we can use this line y hat with small amount of error to predict the value of x. With multiple regression, we have y hat and we have b0, and we have like a number of variables, and we try for each one of them just to we try to predict y hat using these variables. It could be like x1, x2, x3, x4, any number of variables. So we have multiple variables. That's why we describe it multiple regression. With any one of those models, all what we try to do, guys, keep that in mind, our aim is to find, whether it was single regression or multiple regression, our aim is to find the maximum p-value that is achieved by this model, the minimum, we try to, the minimum p-value, not the maximum, sorry. The minimum p-value, we try to figure the model that gives us the minimum standard error, the minimum correlation between the dependent variables. And we try to figure out the model that gives us the maximum F score from Fisher test, the maximum R square score, the maximum R square adjusted score as well, and the maximum correlation between dependent and independent. So that's what we try to figure. We can have different models, as we said before, and our aim is just to figure out the model that gives us the minimum p-value, minimum square error, standard error, minimum correlation between dependent variables, and maximum F score, maximum R square adjusted, and maximum correlation. Talking about R square, we have to keep in mind that R square always goes up when we add variables. Keep that in mind, guys. So that's why it might be tricky sometimes just to use R square only to evaluate your model, because when you add more variables, more dependent variables to your model, R square will go up all the time. That's why we need to use R square adjusted. And we see, the model that has the maximum R square and R square adjusted, or where R square and R square adjusted are like similar, almost like similar to each other. Now, with hypothesis test, we can use a concept usually which is called falsification, as we explained about before, in which we try to disprove something just to get the something else. So we try to disprove the null hypothesis in order just to prove the alternative hypothesis. So this was like a summary about the topics which we explained. Keep in mind, guys, that if we just do all of those steps, if we had the data, usually we start with the question, research question, okay? And we have also, as we said, the theory, and we generate the hypothesis, and we come up with the data. We collect or generate the data, as we said. And number 5, we can just do data pre-processing. Number 6, data discovery. Number 7, we do some queries. We apply some queries on the data. Number 8, we do the data, and we do hypothesis test. Number 9, we can apply, as we said before, regression, and we figure out any regression model. Usually, these steps, we call them data analysis. And usually, we have different people who work on this, guys. So we have a guy we describe as researcher. So we have the researcher, and this researcher usually he works with different people. He works with data engineer, and he works also with another guy who's called data analyst, and he works also with another guy who's called data scientist. Usually, we can have one person to represent all of these people, and sometimes we have we have them like in this way. So for data engineer, this guy, data engineer, he's responsible usually to collect the data. Let me just do it like this. Data engineer is responsible to collect the data, generate the data, and do data pre-processing. For data analyst, this guy, usually he does data discovery, and he can do the queries, and he does the hypothesis test. Usually for data scientist, for this guy, he's the one who deals with regression models. With, if we added here, let's say another step, number 10, we can apply another step here where we can use, let's say, machine learning to predict the future. So this is done usually by data scientists, and usually data scientist is familiar with all of those. The researcher usually is the one who deals with these people, who come up with a question, with a theory, with a hypothesis, and who get the conclusion from these people. So usually they work as a team, and as I said before, guys, in some situations, all of those can be represented by just one person. So keep that in mind. So I hope you understand the whole picture right now. So if we just if we remove, let's say, those things again, in order just to see the full picture, let's just do it. Just remove this port. I'll try to show you the full picture again. Okay. So guys, with we have some R statements which we can use actually. So let's see what R instructions can we use in each one of those levels, let's say. So usually when we collect the data, let me just use different colors. So I will, or let me just use, let's say, this color. So talking about collecting and generating the data. So in this level, guys, what we do in this level number 4. So we can just use, let's say, in R, you can use read.csv to read the data. You can use read.table to read the data. You can use read.excel to read the data as well. We can also, if we want to just read the data, so read the data. If you would like to generate some data, so you can just generate the data, and you can just assume, if you don't have the data, so what we can do usually, we can just assume that these data follows like certain, let's say, distribution. So if our data, let's say, follows, let's say, a uniform distribution, so you can just use R uniform to generate some random samples from uniform distribution. You can, number of samples you want to select, you want to generate. You can use R norm to generate some values according to the normal distribution. You can use R binorm to generate some values using binomial distribution. You have to provide the size in this case, and you have to provide the probability. You can use also
R exponential, you can use R Poisson, so you can just use any one of those to generate some data, which you can use instead of the data which you cannot collect, let's say, as what we did in one of our critical thinking assignments, if you remember. Now, in some situations as well, if you would like to bootstrap your sample, if you have a sample and you want to just you want to try to figure out what population we have, you want to just create like a simulation for the population, then you can just come up with code to bootstrap actually your data. So what we can do actually, if you want to calculate, let's say, if you had your data, you can just find out, if we're talking about the mean, you can just figure out the mean of your data. If we're talking about, let's say, the median, you calculate the median of your data. Whatever you have, you can just generate. So in bootstrapping, guys, we have the sample. And what we try to do, we try to take resample from that sample, as we said before, number of resamples. And by having all of those resamples, we assume that they represent the population. So we can just recreate the population from the sample which we have. That's what we try to do. So in order to do this process, you can repeat the resampling process a number of times. So you can just do it, let's say, you can just do it a number of times, could be like 100 times or 1,000 times or whatever. And you can every time just calculate the mean or calculate whatever you want to calculate from the sample which you have. If the sample contains, let's say, a variable which is called x, so you calculate x, or you can find x from the data which is generated as, so you can just do it. I will write that in the second line, the next line, which is generated as resample from your data frame. So this will generate resample, and then from this resample, you can calculate the mean of the variable you are looking for. Let's say if it was x, and you do that 100 times. So you have your sample. Every time you do it 1,000 times or 100 times, you make resample, and then you calculate the mean. You generate resample and you calculate the mean. You generate new sample and you generate the mean. So by having all of those means, this mean which you got, it's the mean that represents your population. The mean of these means, So if you get the mean of these means, then you will get the mean of the population. If you draw the histogram of these means, you have the histogram of your population, let's say. So this is the concept of resampling in general, as we explained before. So this could be like one thing which you can do if you would like to collect or generate the data using R, as we said. Now, if you would like, let me just remove that first of all. Just give me a second. Okay. If you would like just the next step, which is data pre-processing, in this step, we have different statements which we can use from R as well. So with data pre-processing, you can just, let's say, use na.omit. So you can remove non-values, let's say, from your data frame. You can use also, let's say, sometimes maybe you want to just convert, let's say, one of the columns to be integer, let's say. You can just get that column and you can convert that column, let's say, whatever the column is, which could be like X or could be Y, could be the first name, the last name, whatever. So sorry, it could be like any value. You can just convert that into integer. If it was, let's say, string and has an equivalent, or maybe you can convert that to appropriate data type, whatever the data type is. Maybe you can also standardize your data, so you can just use scale, okay? And if your data frame contains numeric values, then all of these numeric values will be scaled to the standard distribution. You can also, let's say, add or remove certain columns. So you can add certain columns and you can remove certain columns, as we explained before in R. Talking about the next step, which is data discovery, we have different statements which we can use as well in this step. So in data discovery, step number 6, we can use, let's say, you can get number of rows, let's say, from the data frame. You can get also a number of columns, let's say, from the data frame. We can also calculate, we can just write, we can get like a summary about our data frame. We can find, let's say, row names from the data frame. You can find just names, but that will give you like names of columns from the data frame. You can also calculate, we can use, let's say, head to discover the data frame. You can use tail also to discover the data frame. You can use also, let's say, you can use type of, just to know the type of certain column, let's say. You can use length, just to know the length of certain column, let's say. So this is for just discovering the data which you have, and you can use the visual methods as well to discover the data, as we said. So you can use hist to plot the histogram. You can use the pie to like just generate or visualize it as pie. You can use the plot as well, as we said before, and with the plot you have to provide actually x and y. You can use box plot as well, just to see if you have any outliers, and you can just visualize the data where you can see the quantiles as well. You can use some special libraries as well, like the other libraries which we explained about, or which you read about, in R, just to visualize the data as well, if you don't want to use the standard methods which we have in R. The next step, which is getting or doing some queries actually. Let me just remove that. So when we try to request some information or get some part of the data from the data set which we have, then that will be step number 7. And in this step, what we do actually, we can just use, let's say, df, and you can use $sign, and you can just get any column name, let's say. So this will return the entire column, or you can just use df, and you can mention, let's say, row name, and you can mention column name, and that will give you whatever you want. You can also, we can also use df, and let's say you can just add comma, and you can just select, so this will select all rows, and you can select, let's say, certain columns from the data frame. So you can write your own conditions as well, just to get whatever you want. Now, sometimes when we do these queries, if we don't have the data and we have just data which is generated from population, so if the data about the sample does not exist, and we have just generated some data from certain population, then you can use some other methods, like if your data follows, let's say, uniform distribution, you can just use p uniform to get the probability of getting value less than x, let's say. You can just use, let's say, p norm as well to calculate the area under the curve, and that will return the probability of getting value less than x from this distribution which you generated. You can do the same thing with binomial, let's say, to get the probability of getting value less than x from the binomial distribution that has certain size and that has, let's say, certain probability, let's say. So you can just use these techniques if you don't want to generate the data itself. You can just use these functions just to get some queries, about data that follows that distribution. Now, what we can do also sometimes, when this step, sometimes we can just get some description about the data itself. So different types of queries we can apply, not just to select parts of the records or certain records. We can get some description about the data itself. So sometimes we can call these steps like describing the data, or we can just make it as part of doing the queries actually. So you can just get some information about, let's say, you can find the mean of certain column, let's say x, or you can just find, let's say, the median. You can use the function median to find the median of certain column X. You can use the standard deviation. You can calculate, let's say, the variance of certain column X from the data set which you have. You can also get, let's say, the minimum. You can use the maximum. You can use the quantile, if you want to just get the quantile of a certain column. And if you would like, if you have your data right now, and you would like to predict something about the population, then you can just use, as we said before, so this will give you like description or queries about the data which you have right now. But if you would like to test something from the population from which this data was selected or was generated, you can use a T distribution or Z distribution just to calculate, as we said before, the Z value, if you remember, according to what we explained before. So we said before, you can you have the mean, or so this was X bar. You can just predict what is X bar, what is the range, you know. So you can just add standard error, minus and plus. And in order to calculate this standard error, we said if you have the mean, if you want to see what will be the confidence interval, so you can just calculate this error using the equation which we said about before, which was, as we said before, it was Z multiplied by S square root of N. So these Z which we have here, talking about the Z itself, this Z, it can be calculated in R actually using, you can just use, you can use a function which is called, you can use QT. If we talk about T distribution, you can use QT, and you provide the level of confidence and the degree of freedom, and this will return the Z, which you are looking for. You can also use PT, and this will get Z and level of confidence, and will return the Z and degree of freedom. Just give me a second. So PT, then you provide Z with degree of freedom, and this will return the level of confidence. If your data of a size which is larger than 30, then you have to use, in this case, normal distribution. So you can just use Q norm, and you provide level of confidence, and that will return the Z. And you can use also P norm using Z, and you will be able to get the level of confidence. So you can just go in two directions actually. So this is Z, which is used to calculate the standard error if you calculate the mean, as we said before, and if you calculate the proportion, you have to use the other equation which we explained about, in which you have to find standard error equal to Z multiplied by the square root of P hat multiplied by 1 minus P hat over N. So all of that in this level usually. Now, when we talk about hypothesis test, actually, we can just remove what I have here. So in hypothesis test, guys, we have different instructions which we can use as well. So you can just apply according to the type of the test, as we said before. So in hypothesis test, these tests, it could be, as we said, it could be like if the data which we deal with was continuous, then we can apply t-test, and you can write just t.test in R, and you can just provide your data, and you provide so you have different types of tests, as we said before. So if you want to just write one sample test, so you provide your data or your whatever the data is, let's say X or Y, so you provide X, and you provide also the expected mean, you know, so mu equals to mu, and you provide also the direction, so alternative equals to, these could be actually two-sided, two-dot-sided for two-tail test, or it could be greater for right tail test, or it could be less for left tail test actually. So you can just do it in this way, or you can just write t.test as well, and you can provide actually two variables x and y. If you want to just do, let's say, if you want to do two sample t-test, actually you can just provide the two samples x and y, or the names of the columns x and y, and you can provide also the option alternative just to determine, it could be one of these three options just to determine the type of the test. And you can provide also if it was paired test or not. So you can just do true or false for this option. If it was paired, then paired test will be applied. Otherwise, it will be just a two sample t-test. That is not paired. We can also use chi-SQR to apply chi-square test. So you can just use chi-SQR.test, and you should provide the data, but pay attention when you provide the data in this case. You should prepare your data before you provide your data to chi-square test. So don't get the data which you have in the table as is. You need to prepare your data into the tabular format actually. So you need your data to be like this. So you need to have, let's say, if you have two variables, you need to have the first variable here, number one, and variable number two here. So all values in variable number two should be here, and all values in variable number one should be here. And what you get here, you get the number of occurrences of each one of them. So let's say if we would like to test, let's say, the platform, let's say we have, let's assume that we have, let's say, Facebook, we have Twitter, we have Instagram, and we have, let's say, males and females, let's say, wanna test, let's say, gender or sex against, let's say, the platform. This is the second variable. So our data should be represented in these formats in order to apply chi-square test. And so usually we have our data, usually our data which we have, it looks like this. Usually we have, let's say, Facebook, Twitter, Instagram, and we have, let's say, male, let's say female, male, or it could be in other format, whatever the format is. So we don't want the data to be in this format. We want the data to be in this one. So in order to get the data to be in this format, what you can do, be sure to use, you can just convert the data into this format by using table, by converting your data from X and Y into table. So you can just use table, X and Y, you convert the data into table, and then you can use these tables just to apply chi-square actually. When you apply chi-square, you have to just do it like this, and that's what it's actually the p-value, and where you can just evaluate the p-value. With chi-square test, you can save the test, and you can get what is expected as well from the test if you like. What was expected, the expected value, sorry, from this test. Now, talking about other types of tests, you can just apply also, let's say, correlation test. So you can just apply, correlation dot test, and you can apply, find the correlation between X and Y. You can apply all other tests as well in the same way. So let's say you can apply Wilcox dot test as well in R. You can apply Friedman dot test as well. You can apply all other tests as we like the non-parametric test in the same way. Or what you need to do is just write the name of the test dot test, and you'll be able to apply the test. Now, talking about the last part, which is regression. Just remove what we have here. regression. So this is number 9. In regression, in R, actually, you can just create the model easy. So you can just create the model using LM, and you provide whatever Y is, and you can just use tilde sign, and you provide X, what is X is, and you can just provide data equals to your data frame name. So you can just generate the model, and if you like, you can just use AB line to plot this line if you had your data already and as a chart. If you had like scatter plot and you just add the line, you can just display the line in this way. You can also get this model, and you can just add like you can display a summary about this model. You can also so this will give you like a full summary about the model, and this will give you the R squared, the adjusted R squared, the F test with the P value, so you can just evaluate the model, and you can see if this model is a good model or it doesn't satisfy your requirement. And then if you would like to use this model for prediction, you can just use predict in R. You can just predict using this model. I want to predict, let's say, certain things. Be sure to put the value which you want to predict in a data frame. So you can just make a data.frame, okay? And you put in this data frame all columns which you might have. Now, sometimes if this model has more than one variable, if it was not a simple or like single regression, if it was like Y, and if you had, let's say, X1 plus X2, then you have in your data frame, you have to put all of those variables. So you have to put, let's say, the column which is called X1 equals to, let's say, value 1. And the column which is called X2 equals to value 2. So you prepare that as a data frame, and then this data frame can be used for prediction using this model. So this was like a summary about everything we had in this course, guys. I hope this is useful. I hope this is something you will get benefit from. Anyway, if you still have a question about any topic we explained today, it will be my pleasure to have. I will be available during my office hours on Wednesday. You can come up with your question, and it will be my pleasure to help you with your question as well. And if you think that there is any need to arrange like a live session, it will be my pleasure to do that as well. And you can just email me with any question you might have as well. Thank you so much. I wish you all the best. Have a good day. Thank you.